Hello, welcome in. This is the Bitcoin Escape Hatch, and today we're explaining mining using a Sudoku puzzle analogy. And just before we get started, I just wanted to clarify this is a re recording of another mining Sudoku analogy video I did, and a user said that it didn't land. So I wanted to clean it up, make it clearer, and hopefully this will land with some of you. So here we go. Breaking down mining in a super easy way using Sudoku as an analogy. Turns out it's eerily similar, and this is why I used it as an analogy, to the way miners secure the entire Bitcoin network. So let's get into it. First off, picture a Sudoku puzzle. It's a 9x9 grid with some numbers already filled in and the rest are blank. Your job is to fill in those blanks with numbers that are 1 through 9, no repeats in any row or column, or the 3x3 box. It's all about finding the one perfect solution that satisfies every rule, the same as mining. Now map that into Bitcoin. The grid in the Sudoku is like a candidate block in Bitcoin mining. A candidate block is a bundle of recent transactions plus a fixed header of info, like the previous block's hash, because that's how they tie it all together, and a few other things like timestamps and so on. Those pre-filled numbers, they're locked in. You can't change them, like you can't change the hash of the previous block. They're real-world data that must stay intact, like the already filled in numbers on the Sudoku puzzle. In Sudoku, you guess the numbers for the blanks and check the rules, erase if wrong, and trial and error until it clicks. In mining, miners add a special blank called a nonce. A nonce is a random number they tweak over and over. They run the whole block through the hashing algorithm, which is the SHA-256 function, and that scrambles it into a fixed length string of characters. Just like you check the different combinations in Sudoku, the rules in mining, the resulting hash must start with a certain number of leading zeros. That's the difficulty adjustment, and it's set by the network to keep blocks arriving every 10 minutes on average. The network auto-adjusts this target every 2 weeks. Miners are guessing nonces at a mind-blowing speed, quadrillions of hashes per second globally, until one hits a valid hash. But here's the fun part. Imagine mining pools as a massive room full of people all racing to solve the exact same unsolved Sudoku puzzle all at once. That's the miners competing for the next block. Everyone's competing to be the first. These teams of miners, or Sudoku teams, thousands of them are spread across the world, and it's decentralized at its best. The first Sudoku team to yell they've solved the puzzle, or the first miner to yell that they've completed a block, broadcast this to the entire network. Every other miner on the network or Sudoku team checks it, and they usually verify it within seconds. If it's correct, then the miner is rewarded. Currently, the block reward is 3.125 Bitcoin, plus the transaction fees inside that block. This block then gets added to the blockchain, which is kind of like gluing your solved Sudoku puzzle into a giant permanent book of puzzles. Then everyone starts on the next puzzle. I hope this analogy clicks better than the other one I did. Mining isn't creating money out of thin air. It's proof of work, burning real energy and compute to follow the rules and secure the network against fraud or hacks. Sudoku proves you can solve it honestly with logic. Mining proves the same with electricity and brute force. Like I said, I hope this was a much better analogy in terms of Sudoku and mining. If you liked it, let me know. I'm kind of blown away that people are already commenting and let me know what they think of these videos, since I'm such a small channel and only started like a couple weeks ago. So I appreciate it, and I'll see you in the next one. Remember, if you're going to buy Bitcoin, send it to cold storage. Peace out.